I want to draw a triangle here in the sand with sides of 60 centimetres, 70 centimetres and 80 centimetres. But how should I go about it? If I do want to draw a triangle with sides of 60 centimetres, 70 centimetres and 80 centimetres, a ruler is no good to me. I can draw one side measuring 80 centimetres, but I just don't know what angles to make the other sides so that they meet up. So what can you suggest? If you don't know any of the angles in the triangle, it is impossible to draw with just a ruler. I can draw one side measuring 80 centimetres, but to draw the other two sides needs a completely different approach. What I need is a piece of string or a cloth tape. If I attach the cloth tape to this point here on my line and go as far as 60 centimetres to this point here and draw the arc of the circle, that gives me several places all 60 centimetres away where the second side of the triangle might end. Then I do the same for the third side, place it here, measure 70 centimetres away from this point, draw my arc, and this gives me several places, all 70 centimetres away from this point, where the third side of the triangle might end. Where the two arcs cross is both 60 centimetres away from here and 70 centimetres away from here, and is the third vertex of the triangle. To complete the triangle, join the vertices like this. I want to work out the length of the pier here. I can measure where it starts, but I can't measure where it ends because it's out in the sea, and I can't go onto the pier itself. But I do have this measuring wheel and I do have this pole. So how can I work out the length of the pier? Here's a clue. I can line up the pole with one end of the pier like this, and I can line up the top of the pole with the other end of the pier like this. Let's draw a diagram. Here is the edge of the beach. Here is my pier with the end sticking into the sea here. This is my pole. Here is my line of vision to the end of the pier here. And here is my other line of vision to this end of the pier here. If I join my two lines of vision here with a line that is parallel to the pier over here, I have got two triangles, a small triangle here and a larger triangle this side. Does that help? Let's look at the angles in these two triangles. This angle here is equal to this one because they are vertically opposite angles. This angle here is equal to this angle here because they are alternate angles. And also, we've got this angle here is equal to this angle here because once again, these are both alternate angles. Both triangles contain the same 3 angles, which means they are similar triangles. This also means the corresponding sides are in the same ratio. Remember, I want to work out the length of this pier. So what can I measure to work this out? Because these 2 triangles are similar, the ratio of this length to this length is the same as the ratio of the pier to this length here. Now, if I measure this length, and this length, I should be able to work out the length of the pier. So let's take some measurements. This length here is 80 meters long, and this length here is 2 meters long. That's 40 times longer. Now, the distance between my 2 lines of vision is 4 meters. So that means the length of my pier must be 40 times 4, which is 160 meters long. Out at sea, there's the end of what used to be an old pier. How can I work out how far away it is? I've got a trundle wheel to measure distance and an angle measurer to measure angles. So how can I do it? Here's the setup. Here's the beach. And here's the old pier out at sea. I am here. If I draw a baseline along the promenade and draw lines from each end out to the pier, I can measure this angle between the baseline and the direction of the pier, and then go to the other end of the baseline and measure this angle out to the pier. Once I know these 2 angles and the length of the baseline, I'm able to work out the length of these 2 other sides, which will tell me how far away we are from the pier. So let's take some measurements. Here are my measurements. I've made the baseline 500 meters along the promenade. This angle here is 75 degrees, and this angle here is 80 degrees. So you should be able to work out the length of the other 2 sides of the triangle, which will give us the distance to the old pier. One way of solving this is by doing a scale drawing. I'll draw a baseline 50 centimeters long instead of 500 meters, and that's 1,000 times smaller. I'll draw an angle this end, 75 degrees. That stays the same on a scale drawing. So I'll draw the line here. I'll also make an angle of 80 degrees this side. So I'll draw a line off here. And where the lines cross is where the old pier is. On my scale drawing, this side is 113 centimeters long. And on my scale drawing, this side is 110 centimetres long. To get the real distance, we have to multiply each side by 1,000. So the real measurement is 1,130 metres long for this side and 1,100 metres long for this side. So now we know how far out to sea the old pier is. If I tie myself to this post, what is the locus of all the places that I can go to? And the length of my rope is 2 metres long. If I am always at the end of my tether, then the locus of all the places that I can get to will be a circle with a radius of 2 metres. That is the length of my rope. I've got a 6-sided cake here, and each side is 5 inches long. How can I cut it into 5 equal pieces? First, I've got to find the centre of my cake. Because this is a regular hexagon, if I draw diagonals, they will all meet at the centre. The next step is to work out the distance around the outside of my cake. That's the perimeter. And that's 5 inches multiplied by 6 sides equals 30 inches. To divide the cake into 5 equal pieces, I can divide the perimeter into 5 equal lengths. And that's 30 divided by 5, and that's 6 inches. And then make a cut around the cake every 6 inches, like this. But can you prove why this works?